Superspace video, and in this one I want to talk about the fourth dimension, which is the direction of the very small, and I want to look at it in terms of the flatland analogy, in which we examine our universe as a two-dimensional field in order to simplify the picture and try to understand the fourth dimension in this way. So in the flatland analogy, we look at our spatial universe as a two-dimensional field. So we have this flat field of space. And if there's an entity living, a flat entity living in this field, so this is not standing on the field, this entity is flat like the field and can move in these two fundamentally different directions or degrees of freedom. So it is part of this flat sheet and is unable to go up off of the sheet or down beneath it. It does not even comprehend that up and down exist in terms of these added dimensions. So if there is a three-dimensional reality underneath the sheet, like some sort of Jaws shark, hopefully not, and it bumps up against the sheet, that first little bump will appear as a dot, right? A little dot in the sheet. So if this entity here cannot see underneath, it will only see a dot, okay? So in this analogy, a flatland entity would believe that a dot had appeared, and if that three-dimensional entity went further in, it would look like a circle has appeared within that flat sheet of space. And so the let's pull up a new layer real quick here and color it in. So in this analogy, our universe could have dimensions lying alongside it that we don't observe or don't realize we're observing, perhaps, which is the case actually, because these dimensions do affect our universe constantly. So not realizing these dimensions lie alongside, this flat entity, which is very badly drawn, is going, look, there's a dot, and there's a circle, and there's a bigger circle, right? So this is the tip of something coming up. This is something emerging further in and emerging further in. You could say they're going just into the sheet, or you could say they're, passing through even, and it would only see this cross section within its field. So the point I want to make is that this is actually what is happening in our 3D universe with the fourth dimension, which is the direction of the very small. So that might be hard to get our mind around, but it really is the same exact thing as the flatland analogy. So here now we have a 3D cube. So this 3D cube has 3 degrees of freedom. Okay, that's a badly drawn cross with the wrong direction, but we have up and down, we have left, right, and then we have, sideways. So we have 3 degrees of freedom here. Now, if you imagine some entity emerging from the 4th dimension, and we'll have a little 3D guy here, the big bug eye, and now he's 3D, so he's got solidity and mass. He's not just a flat sheet, and he can move in 3 directions, 3 degrees of freedom. And if something was emerging from the 4th dimension, it would appear as a tiny ball, a point particle. And then if it came in further, it would appear as a larger ball, not as just a circle, but as a ball. And then if it came in further, it'd appear as a larger ball with content and solidity and mass, right? This is the exact same thing as the flatland analogy. And it might have a shape, right? Because say it's emerging in, like if we go back to flatland, say something is shaped oddly, and the portion that emerges into the sheet is shaped like this, right? It won't appear as a circle, it'll appear as some strange squiggly thing. Some alien from the 3rd dimension. So, but it's actually emerging from underneath. And same here, right? If something was coming in, but it wasn't just coming in a completely circular manner, it might appear, to have a shape. Maybe like a cell or something. So this is actually the exact same thing. And what we are failing to understand is that so we have the macro universe, which is like the flat sheet, is the linear 3D space. But then we have the micro universe, in which we are looking at things which are smaller and smaller, smaller and smaller balls. But at some point that emerges into our 3D space, at some point it is no longer smaller, it's emerging from a 4th direction or dimension, and that is the direction of the very small. So this is, again, exactly the same as our flatland analogy. It's just that we are failing to see that at fundamentally smaller levels of physics, we are no longer, let's go back here and get a new layer going, we are no longer getting smaller, we're actually moving in this fundamentally different spatial direction. So that's the main concept, the unrecognized concept of superspace theory and of physics that we are failing to see, is that these point particles are connected to deeper dimensions, and going inward, once we get to fundamentally smaller levels, is moving in a 4th direction. So to clarify this a little bit more, let's look at a 3-dimensional donut, which is sometimes used to describe our universe, and this has lower resolution, so I will make a smaller brush because the resolution is so low. So the lines will be blurry, but that's okay. So when we talk about our universe and whether our universe has an edge, people sometimes compare it to a torus or donut shape in which an entity living on the surface of this, like an ant, or a strange little creature, it could be an alien, who cares, and it would crawl around, right? But there would be no, it would never reach an edge, right? Because it's on the surface of this torus, right? So that's often used to describe why we may not be able to reach an edge of our universe, because we're sort of in this donut within higher dimensional space. But what we're not quite clarifying here is that even though it's held on this surface, there is a dimension inside, right? And outside, but let's talk about inside. We can pretend that this analogy is limited to the surface, but you really can't make this analogy without acknowledging that there's space inside of this donut, and that inside content is, in this analogy, another dimension, right? So if we pull up another layer here, so looking at it that way, and I'm going to draw a really bad donut here because I'm not an artist, right? But let's say this is a 3D donut, right? So the surface of the donut is a dimension, but the inside content is also another dimension. So in terms of topology, we can look at it as in this way, that the 3D space we live in is like the surface of things, not too simplistically. I mean, the surface includes, our insides. It's not like our, intestines are in another dimension, although some people, who knows, but regardless, the surface you can see as a dimension, and then the content, the inside, the deeper, what fills the surface. So in this donut analogy, what fills the surface, and then here inside, what fills the surface, that in this analogy would be another dimension. And that's exactly what it is in our 3D space. We are actually 3D entities that can only move in what you could say is 3D surface directions. We can't move inward into fundamentally smaller levels of space, not actually smaller, but distant in the fourth dimensional direction. And so we think of it as just tinier and tinier, even when it reaches fundamentally different levels of size, which are no longer size at all, and are no longer size within mathematics, because math does not speak of size at that point. It just is moving in a different direction. So if we look at the idea of the universe as a torus, and we look at it not having an edge because we're held on the surface, this actually shows us the reality that what fills the inside of the surface at fundamentally smaller levels is another dimension. And one way I have described this, and one more layer, One way that I've described this is to look at it as if the realms of the very small, so let's do this as a flat sheet, and we have things going smaller and smaller and smaller. But at fundamentally smaller levels, the realms of the very small, it's like a tunnel going in a fundamentally different four-dimensional direction. So a ball has this content that fills it, that when we go inward far enough, that curves into this fourth dimension. It's as simple as that. So in our space, gravity is the curvature of a hole, and a ball like a planet actually has a center that opens into this fourth dimensional direction. And a lot of what we see in terms of the strangeness of quantum physics and quantum realities is because these realities exist in deeper dimensions of space in this greater multidimensional block universe. And so we are thinking of them as all being held here on the surface and going, why do they behave so strangely? But they behave so strangely because they're not here, they're down here, right? In these energetic waves and excitations or holes in fields. And if we can understand that they exist in progressively deeper fields lying alongside each other, as in a cyclic universe model where these fields lie alongside each other and can bump each other, and they say that's one model of how the Big Bang occurred, is two fields or branes bumping each other. If we can understand that the realm of the small is leading us into deeper fields of multidimensional space, all of this will start to shift and we'll understand things in an entirely new way. So those are just some ways of trying to show how our three-dimensional experience is one in which we are experiencing a surface with a deeper content, and that depth that fills up the surface leads into another dimensional direction. So again, I just wanted to try to show how both with the torus universe, but also with looking at our 3D space as exactly analogous to FLATLAND, where tiny dots can be the emergence of energies into our 3D space from deeper dimensions in a fundamentally different dimensional direction. That's what they appear as, tiny dots. And when we think of a fourth dimension, people in 3D space, very simple and awkward looking people, will always say, well, we can't point to where this fourth dimension is. We can't point to it. It's at some kind of right angles to 3D space, which our mind can't process. Well, actually, our mind can process it. We just aren't recognizing what it is. That the fundamentally small is that fourth dimension. What creates the mass of our 3D space is coming in from deeper fields in a fourth dimensional direction. And so the energies and forces within these deeper fields are entering our own 3D space, but here it's a 2D sheet, and affecting it. And I won't get into how this creates what we experience as mass, but that's exactly what is happening, is that we are observing all of these things affecting our single field of space and not realizing that they're connected to these deeper fields that lie in the direction of what we think of as small, but isn't small at all when we reach fundamentally deeper levels of physics. Hopefully that helps with understanding superspace theory, and I appreciate your watching. Thank you very much.